Okay, welcome back. We're going to do some more of this homework from 2-6. And the next problem we're going to do is the water tank problem. Now, I struggled with this one in class, so hopefully I'll be able to explain it one more time. A little bit different than I did last time, and here we go. So, we have an inverted conical water tank with a height of 6 feet and a radius of 3 feet. And this tank is drained through a hole in the vertex of it, right here, at a rate of 7 cubic feet per second. Okay, and so it's draining, so that's going to be a negative 7 cubic feet per second. Okay, the water's coming out the bottom. All right, and so now what the rate of change of the water depth when the water is at 2 feet. Okay, so that's what we are trying to find when the water is at 2 feet. So now, first thing we want to see is that we've got a height of 6, a radius of 3, but the height is what's changing because it's going down, the water's coming down. And so we are looking at a height of some other height of 2. So when the water gets down and the height's 2. Okay, so that's what we want to look at. So we're looking at the volume of a cone. A volume of a cone, and technically the volume of a cone is 1/3 pi r squared h. That's the formula for the volume of a cone. Okay, but now if you'll look at the question, it says let V be the volume of water in the tank and let H be the depth of the water. Write an equation that relates V and H. V and H. Well, what about R? Where's R? Is R changing? Oh yes, this time R is changing. The last problem, the radius didn't change. We were dealing with the cylinder and the radius never changed. But this time, the R is most definitely changing. So how are we going to do this? Okay, so what we're going to do is we're going to rewrite R in terms of H. We're going to solve for R in terms of H. That's the official math way of saying it. And the textbook is saying let's use similar triangles to do this. Okay, so here's the similar triangle that we're looking at. It's right here. Okay, so this is R and this is H. Okay. And so R was 3 when H was 6. And so that means R over H is 3 over 6, no matter what R and H are going to be. We have a smaller triangle for R and H, and it's still going to have R over H is still going to be this 1/2 ratio. It's still going to be. So no matter what R and H are, they're still in a ratio of 1:2, all the way down, no matter where it is. Okay, so now we can take this and solve it for R. If I multiply both sides by H, then I get R is 1/2 H no matter what. So that's what I'm going to do. I'm going to solve for R. All right, this is just variable manipulation. So now R is no longer R. R is now 1/2 H, or let's call it H over 2. And so now when I do this, I'm not taking the derivative yet. I have H, we'll go ahead and write squared multiply this, and I have 1 over 12 pi h to the third. Okay. That is the answer in the first blank. That is the volume. Or you could say it's pi over 12 h to the third. I think that's what it says. But that's what goes in the first one. That's our volume formula using only one variable. Okay. And that goes to that relationship of similarity. The ratio of the sides, the radius to the height never changes no matter what. The ratio is always going to be 1 to 2. The radius is always going to be half the height. And so we can replace r with h over 2 and go from there. Okay, so now we want to do dv dt. We want to do the derivative of this with respect to time, and we're going to do our power rule. And so I'm going to have 1/4 pi h to the second times dh dt, because we always got to do the derivative of the inside function. And so now it's pretty straightforward. At this point, we just start plugging in our information. So our, whoops, didn't want to do that. Our dh dt, okay, or our dv dt, I'm sorry, we're solving for dh dt, but our dv dt is -7, and then we have 1/4 pi, our height that we're looking at, our instant height is 2, and we're solving for the dh dt. That's what we're looking for, the rate of change of depth, which is our rate of change of height. That's what we're looking for. All right, so these are going to cancel, and I'm just going to be left with -7 is equal to pi dh dt. So if I solve for dh dt, I'm going to have -7 over pi. Type that in your calculator. And let's see if we can't get this right. And I get -2.23. And the height is centimeters, so this is going to, excuse me, feet. So this is changing at a rate of feet per second. Okay, so now that's kind of tricky. I know, and I don't know that I did a very good job of explaining it, but you keep trying, okay? Keep trying. It's just math, y'all. It'll be okay. One more video for number 7.